Hey guys, it is Campbell here, and today we are finally going to be finishing the 2024 AP Calculus BC FRQ with question number 6. You know what, let's go ahead and just get right into it. Question 6 reads, the Maclaurin series for function f is given by the sum from n equals 1 to infinity of n plus 1 times x to the n over n squared times 6 to the n and converges to f of x for all x in the interval of convergence. It can be shown that the Maclaurin series for f has a radius of convergence of 6. Part A says, determine whether the Maclaurin series for f converges or diverges at x equals 6. Give a reason for your answer. So for this one, we first need to plug in 6 to that series. So it is the sum from n equals 1 to infinity of n plus 1 times 6 to the n over n squared 6 to the n. As you can see, we've got these two 6 to the n's. Those will cancel out and give us the series from n equals 1 to infinity of n plus 1 over n squared. Alright, now we need to analyze the convergence of this series. I think I am going to use the limit comparison test, and I'm just going to compare it to, I say we cut out this 1 and make it n over n squared, which is just going to be 1 over n. And over here, we'll write that we're using the limit comparison test. And it's going to be the limit as n goes to infinity of our first series, which is n plus 1 over n squared, over the second series of 1 over n. Oh, and we do need to write which series we are comparing it to. And we do need to say that the harmonic series diverges. And so now we can simplify this. Oops. The limit as n goes to infinity of n plus 1 over n is, of course, going to be 1. And since 0 is less than 1, which is less than infinity, f diverges at x equals 6. On to part B, it can be shown that f of negative 3 equals the sum from n equals 1 to infinity of n plus 1 times negative 3 to the n over n squared times 6 to the n, and that is the same as n plus 1 over n squared times negative 1/2 to the n. And that the first three terms of this series sum to s sub 3 equals negative 125 over 144. Show that f of negative 3 minus s sub 3 is less than 1 over 50. So, this is where we need that series error bound. Let's go ahead and write down our series. The sum from n equals 1 to infinity of n plus 1 times negative 3 to the n over n squared 6 to the n. Now, because we've got this negative 3 here and nothing else negative in the denominator or numerator, this is an alternating series. So I can simply use the alternating series bound, which states that the error, or what it shows us there, f of negative 3 minus s sub 3, is less than the fourth term. So we can call that a sub 4. And so we know that our error, or our remainder, minus s sub 3, is going to be less than the absolute value of 5 over 16 times 1 over 16. And this is going to give us that the remainder is going to be less than 5 over 256. And so we know that the remainder is less than 5 over 256, which is less than 5 over 250, which is equal to 1 over 50. So we know that the remainder is less than 1 over 50. Alright, on to part C. Find the general term of the Maclaurin series for f prime, the derivative of f. Find the radius of convergence of the Maclaurin series for f prime. So it wants us to find the general term, which means we can just leave it in this form. So remember, taking the derivative is just as easy as deriving this expression with respect to x. So f prime is equal to the sum from n equals 1 to infinity of n plus 1, and then we're going to take the derivative of x to the n. That is going to be n x to the n minus 1 over n squared 6 to the n. Further simplification is going to give us the sum from n equals 1 to infinity of n plus 1 times x to the n minus 1 over n 6 to the n. Now you could do a test to determine the radius of convergence for this, or you could recall that the radius of convergence of the derivative of a series is going to be the same as the radius of convergence of the original series. So the radius of convergence is 6. And that's all. And finally, part D. Let g of x equal the sum from n equals 1 to infinity of n plus 1 times x to the 2n over n squared times 3 to the n. Use the ratio test to determine the radius of convergence of the Maclaurin series for g. So it tells us use the ratio test. So we are going to start out with the limit as n goes to infinity of, remember the top is a sub n plus 1, or k sub n plus 1, whatever letter you use. So this is going to be n plus 2 times x to the 2 times n plus 2 over n plus 1, oh, I'm sorry, this is not n plus 2, this is n plus 1, it would be 2n plus 2. Times 3 to the n plus 1, and this is going to be over n plus 1 times x to the 2n over n squared to the times 3 to the n. Now we can simplify this, or at least make it nicer to look at before simplifying, which is what I always like to do. So this is just going to be the same as the top right here, n plus 1 times 3 to the n plus 1, and then it's going to be times our reciprocal n squared 3 to the n over n plus 1 x to the 2n. Our 3 to the n and 3 to the n plus 1 will cancel out, leaving us 3. Our x to the 2n plus 1 and x to the 2n will cancel out, leaving us x squared. And now we will have the limit as n goes to infinity of n plus 2 times n squared times x squared over n plus 1 times n plus 1 times 3. That's what's wrong. I forgot a square over here. This guy should be squared, 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 squared. Alright, make sure you don't make a silly mistake like that, because you will lose at least a couple of points. Alright, and so now because we are doing the limit as n goes to infinity, we can pull out these guys, sort of treat them like constants. Oh, and that's the other thing I forgot. Make sure you've got your absolute values around this expression. That is important. The absolute value of x squared over 3 times the limit as n goes to infinity of n plus 2 times n squared over n plus 1 squared times n plus 1. Now, the order of the numerator and denominator are going to be the same, so this is just going to leave us 1. So, according to the ratio test, x squared over 3 needs to be less than 1, which means that x squared is less than 3, which means that the absolute value of x has to be less than root 3. So our radius of convergence is going to be root 3. And that is all for question number 6. I think they made this probably a little bit easier. I mean, series are always hard. Series is one of the hardest topics for Calc 2 students. That was definitely the hardest part for me taking Calc 2. But I think because it's the last question, you've gone through this whole 3-hour examination, they want to make this last one a little bit easier, even if series are a harder concept to grasp. But yeah, as you can see, this one was really not that complicated. Our answers are mostly numeric, not a lot of justification. And so yeah, that's going to be it for the 2024 AP Calculus BC FRQ. The series is going to continue with the AB questions. I just prefer Calc 2, so I don't know. I wanted to start with this one. If you guys enjoyed this, please consider leaving a like and subscribing. Let me know if you found it useful. Leave a comment letting me know what other topics you want me to cover. And I will see you guys next time. Bye.